What's poppin', dogs? Mr. Allen here. We got ourselves a beast of a problem here involving Newton's law of cooling. Perhaps his coolest of laws. No. All right, so we got Snoop Dogg and Martha Stewart just pulled a fresh calzone out of the oven, right? They did like a cooking show or segment at some point together. This is what it was. All right, it has a temperature of 165 degrees Fahrenheit. They set it on the counter at room temp, which is 70 degrees Fahrenheit. And in 20 minutes, the calzone is 140 degrees Fahrenheit. Did I mention we are in Fahrenheit, not Celsius, all right? This is America. So write a function, u of t, to model this situation. So the whole dealio here is that I got to find my constant right there, right? My constant, like my cooling constant. It's ice cold. Not ice cold. It's 140 degrees in 20 minutes. So we're going to start plugging some dope things in. Well, let's see here. The T is my room temp, which would be our 70 degrees. The U naught, that is my initial temp of 165 degrees. All right. Now I've got this U of T and the K and the T that are unspoken for, or perhaps they are. In 20 minutes, T being 20, my temperature is 140 degrees. And I'm left with only K that I can solve for, right? E, that's a number, bro. That's not a variable in case you got like confused in this whole situation. All right, so I've got 140 for my U of T equals my ambient temp, my room temp, which is 70 plus, and then we have U naught, which is my initial, so 165 minus my room temp, which is 70, E raised to the K, and then T is going to be my time, which is 20 minutes, so times 20. Woo, woo. All right, we got a couple things we can do here. I can subtract 70 on both sides, and I can do a little bit of, combine them right there in the parentheses. If I subtract 70, I'm going to get 70 over here. 165 minus 70, that's going to be what, 95? And then it's E raised to the 20K or K times 20. We can leave it as K times 20 if you like. All right, that's not too bad. So now what? Well, I have 95 times E, so I can actually divide both sides by 95. And now I'm going to have, let's see here, 95, 95. And I'm just going to leave that as 70 over 95. We could simplify it, but I'm not going to right now. I'm choosing not to, bro. It really doesn't, I don't have to do it, all right? I'm not going to do it if I don't have to. Okay. So now I have this fraction equals E raised to the KT. How in the heck am I going to solve for E? Did I just say solve for E? Solve for K. All right. So I'm going to take the natural log on both sides. That's going to undo my E right there, leaving me with just K times 20 on the right-hand side. And on the left, I'm going to have natural log of this wonderful little fraction here, 70 over 95. Again, I don't care about what that simplifies to because I'm plugging in all in my calculator anyways, right? So now last thing I'm going to do here to solve for K is I'm going to divide by 20 on both sides. And we can plug that whole mess into our calculator. So let's do that, right? So turn this bad boy on. I'm going to take the natural log of 70 divided by 95, close my parentheses, divide by 20, and I get negative 0.015. That equals K. So now what I'm going to do is I'm going to store. I'm going to hit the store button, and then I'm going to choose alpha, and it's going to be K, which is the parenthesis there. And then I can hit enter, and now it's stored in my calculator as K. That's dope. That's dope. Now let's write down just for reference here that K is approximately negative 0.015 and change. I'll put the ... We got more numbers, bro. Okay. Woo. Now what? Well, let's say this. We can write our function here. We can write our function as U of T equals, now our room temp, which is 70 plus, and then we have our U naught, which was 165 minus then my room temp of 70. So I'm going to go ahead and just erase that right there. And we're just going to put our 95. So 95 E raised to the, well, what's my K right here? It's this ugly mess right here. So negative 0.015 and change times T. Now I have myself a function of time, right? The temperature as a function of time as it cools. I can throw in any amount of time that I want here and find out what that temperature is going to be, right? So let's just say for fun, what's the temperature in 30 minutes? So what's the temp in 30 minutes? Well, I could do U of 30 equals 70 plus 95 e to the negative 0.015 times 30. We're saying after 30 minutes, what's this temp going to be? Bust out that TI. And luckily, we got that K stored, dogs. So I'm just going to do 70 plus 95, then E raised to the K, alpha K, right, times 30. Hit enter. It's going to be 130 degrees, roughly, right, after 30 minutes. That makes sense. 20 minutes was 140. Another 10 minutes, it cools a little bit more. Dope. Next question. Next dope question. What if I wanted to know when it's going to be, how about 115 degrees? So when is it going to be 115? Well, what I can do is I can actually plug this into my graphing calculator. I'm going to set this function into my calculator here. Sorry, the blue one right there. 70 plus 95 e raised to the, put the K in there, right? So that way it's unrounded. Hashtag YOLO, dogs. You only round once. Throw that K up there. And then it's going to be an X because that's my variable, right? So T will be my X here. That's going to be K in my calculator. Arrow down, or enter down, excuse me. And we said, when is it going to be 115 degrees? So 115 will be my Y2. And then I'm going to need to adjust my graph window. So let's see here. First, I'm going to hit the zoom standard. Let's just do zoom 6 and see what happens. We're probably not going to see a whole lot. Yeah, bro, I see nothing. I see nothing. Well, let's see if we can maybe adjust our windows in an intelligent manner, right? The U of T, that's the temperature that it is. It started at 165, right? So I'm gonna go at least that. Let's go with our Y max as like 200, right? Just I want to see a good amount of that graph, right? And then my X, well, we're saying after 20 minutes it was that temp. 30 minutes it was whatever, it was 130 degrees, right? So let's go to like 60 minutes, okay? That sounds good. That sounds reasonable. And maybe we'll see a little bit more. Ooh, it's showing up. It's showing up. Let's see if we can see the intersection here. Oh, bingo bango. I see it, dogs. I see it. So now I'm going to hit second calc. I'm going to find that intersection of those two lines. Hit enter, enter. They're only hitting each other once. They're only intersecting once. Hit enter one more time. Boom. It says at 115 degrees for Y, right? 48.936 minutes. So we got 48.936 minutes when it's going to be 115 degrees until 115 degrees Fahrenheit. Woo! Woo! Those are some cool questions there, man. Now, I got one more. As time goes on to infinity and beyond, often a math question. What's going to happen? Like, what's going to happen in the context of this problem as we continue on forever and ever in the time direction here? What's going to be happening to this calzone? Well, perhaps it's going to be approaching that room temperature of 70 degrees. So as time goes to infinity, my calzone approaches room temperature, which is 70 degrees. Those are all dope questions that can be asked on a test involving Newton's law of cooling, his coolest of cool, ice cold laws. That's all I got, dogs. That's all I got. Hope you enjoyed it.